Hi everyone, my name is Siemensma and I'm going to tell you about our work on Bayesian decision making in a swarm of miniaturized robots for surface inspection application. In our problem, a group of robots, shown on the left, must inspect and classify a 2D tiled surface, which is shown on the right. The surface consists of vibrating and non-vibrating tiles, shown here in black and white. The goal of the swarm is to classify the surface as majority vibrating or majority non-vibrating. Here, our experimental setup is shown. On the left, you can see our real experimental setup, and on the right, you can see our calibrated simulation in Weebots, which we use for modeling and optimization. The robots perform a random walk on the tiled surface, avoid collisions as they move, and make binary observations of the surface vibration. They continuously share their information with the rest of the swarm. Let's dive into the algorithm we use. The robots perform a random walk. On fixed observation intervals, the robots observe the surface locally as vibrating or non-vibrating. This information is shared with the rest of the swarm. Each robot holds a beta distribution to model the proportion of vibrating tiles in the overall setup. Upon making an observation or receiving a message from the other robots in the swarm, the distribution is updated using a Bayesian approach. The binary final decision about the state of the surface is made when a robot is sufficiently confident according to its beta distribution. We consider three information sharing approaches. First, no feedback considers the case in which the robots share their current observation. Second, positive feedback is similar, but the robots share the value of the final decisions when made. And last, we consider soft feedback. In this approach, each message is calculated using the current belief about the state of the surface as well as the most recent observation. We perform simulation studies. Our first result is generated for a fixed swarm size of 5 robots. Here we see that the soft feedback strategy, denoted by US, drastically reduces decision times. Moreover, the decision accuracy is not hugely influenced by this decrease in time. We can see that these results hold over a variety of fill ratios, also close to 0.5, which is the hardest case. What about increasing the swarm size? We see that decision times decrease with increasing the swarm size. However, decision accuracy does not grow proportional to the swarm size. We hypothesize that this is due to the increase in collision avoidance time when putting more robots on the surface. Increasing collision times might cause a lower quality sample. In conclusion, we present simulation studies of the performance of a swarm of robots in a surface inspection task. In particular, we study how different information sharing strategies and different swarm sizes impact the decision accuracy and time of the swarm. Thank you.